Good morning, cores, and welcome to Wednesday. Today we are going to talk about the highs and lows of air pressure and how air pressure can affect the weather that we see. You've probably heard people talk about pressure systems moving in before. Usually on meteorologist radars, they will show us the air pressures moving in, and they broadcast these to the public. You can usually identify a high or low pressure system based off of the symbols that the meteorologists choose to use, and I will show you those symbols today. So first thing I want you to do before we get started is open your scientific notebook and go ahead and turn to the very next page you have. I want you to call this page air pressure, or you can call it highs and lows of air pressure. Either of those will work. As we move along in the slideshow, you don't necessarily need to take notes, but please listen carefully. There will be several questions in Canvas for you to answer in your scientific notebook when we're done with our lesson today. So first thing we want to talk about is that air is all around us. We've been learning about the atmosphere and weather, and we know from our study of the atmosphere that we live at the bottom of the atmosphere. Of course, this layer is called the troposphere. The troposphere has the most air pressure because it has the most air pushing down on it, and Earth is pulling it closest in by gravity. This creates a lot of air pressure, and a lot of air pressure coming down on us at pretty much all times. In fact, there is 14.7 pounds of air pressure coming down on each square inch. Pressure varies from day to day at the Earth's surface. This is not because the Earth's surface is different in elevation, but because it is heated differently by the sun. And so not all of Earth's surface is getting the same equal treatment or the same equal heating from the sun, so some areas have warmed more than others. Areas which have warmed by the sun more have a lower air pressure because the warmed air wants to rise. These areas are called low pressure systems. Places where the air pressure is high is called a high pressure system, and these areas are usually cooler. So how do air pressure systems turn? So low pressure systems and high pressure systems turn in different ways depending on that heating. And you can see in this graphic that we have a northern hemisphere and a southern hemisphere. Right in between these two is the equator. So think of the equator being right here. So the northern hemisphere is everything above the equator, and the southern hemisphere is everything below the equator. A low pressure system, when it happens, its winds will turn north of the equator at a counterclockwise motion. So north of the equator, it's turning counterclockwise. So the winds are moving this way. South of the equator, though, these winds turn clockwise. So southern hemisphere, which is south of the equator, turning clockwise. High pressure system is the exact opposite. North of the equator, high pressure systems are turning clockwise. And south of the equator, high pressure systems turn counterclockwise. These are always opposites of each other. So let's talk about the steps that happen because of a low pressure system. A low pressure system has lower pressure at its center than the areas around it. So when a low pressure system happens, winds will blow towards that low pressure. So they're going towards the lower pressure. Air rises in the atmosphere where these winds and that low pressure meet. So when the winds come in, they'll crash into this low pressure system and they'll start to rise in our atmosphere. As it begins to rise, water vapor within the pressure system condenses, and it begins to form clouds and often precipitation. Remember that precipitation could be rain, snow, sleet, hail, any of those types of precipitation. Because of Earth's spin and the Coriolis effect, winds of a low pressure system swerve counterclockwise north of the equator and clockwise south of the equator, and this is called a cyclonic flow. So why do we think this happens? Let's talk about how we can see this. A low pressure system on a weather map, one that's shown to us by meteorologists broadcasting on the news or online, is usually labeled with a red L. And not only a red L, but it will also be labeled with this graphic. It looks like half circles and a line, and it's usually red. Generally, a low pressure system brings stormy weather and strong winds. So when we see it on the radar, we'll probably hear about storms in the meteorologist's forecast. Remember that in a low pressure system, the water vapor is beginning to condense, and that's what can bring these storms. A high pressure system, in contrast to the low pressure system, has higher air pressure at its center than the areas around it. So let's take a look at the steps that happen because of a high pressure system. The first step that happens is that winds blow away from the high pressure. So unlike the low pressure, winds are blowing away from it. So they're scattering outwards from the high pressure. The winds of the high pressure system rotate clockwise north of the equator and counterclockwise south of the equator. And this is called an anticyclonic flow. So this is the the opposite of the cyclonic flow. Air from higher up in the atmosphere sinks down to fill in the space that's left as air is blown outward. So unlike a low pressure system where air is rising, a high pressure system causes air to fall from higher up in the atmosphere or sink, and it fills up the space as the wind blows air outward. So let's talk about how a high pressure system looks on the weather map. A high pressure system on a weather map is usually labeled with an H, a blue H, or this symbol here, which is a line with triangles on it. And that shows a high pressure system. Generally it is blue, and a high pressure system brings dry or low humidity weather. It will cause more evaporation of water at the surface, so instead of condensation like in a low pressure system, a high pressure system is causing evaporation, and this is what causes that lower humidity. Remember that humidity is the count of how much water vapor is in the air. So a low humidity has low amounts of water vapor in the air. Sometimes high pressure systems can even lead to a risk of wildfire because of this low humidity and this dry landscape. So as we learned a couple of weeks ago, we know that air pressure, air density, and air temperature are all related to one another. And air pressure depends on that temperature and density. So these are three variables. They all work together. And when density of the hot air is high, air pressure is also high. If we heat that air or raise the temperature, then the air pressure gets even higher. So high density, high temperature, high air pressure. As air pressure depends on temperature of the air and the density of the molecules. In contrast, low density and low temperature will bring low air pressure. Here's a law that we will need to know, one that's important to us and very important to atmospheric scientists. They use this math equation called the ideal gas law to describe how pressure, temperature, density, and volume are related to each other. They call these equations the ideal gas law, and they use Kelvin to measure the temperature in them. So when they work with the temperature inside of this equation, they're always working in Kelvin, not Celsius or Fahrenheit, but Kelvin. The two ideal gas laws, which are related to one another, and we can manipulate to get back and forth from one another, is that air pressure will equal air temperature times density times constant. And we'll talk more about that constant later this semester. And we know that pressure times volume will equal temperature times constant. This equation will help us explain how weather works, such as what happens in the atmosphere to create warm and cold fronts and storms. So that was the lesson that I had for you guys today. And so what I want you to do is take the information that we have talked about and go into your scientific notebook on that page we just created. And I want you to answer the questions below in the Canvas page. So in Canvas, if you're watching this from YouTube, you're looking for the air pressure systems, Wednesday, October 21st. And you want to answer the questions at the very top of the page. There are 6 of these questions, and I want you to answer them as thoroughly as you can. I hope you guys have a great day. Thank you for being here. And happy Wednesday to you all.